Good morning, everyone. Welcome to the keynote speaker track of communication technology at the International Conference of Artificial Intelligence, Communication Technology and the Smart City. We have three honorable keynote speakers with us. Let us introduce the first speaker of the day, Dr. Nilanjan Dey. Dr. Dey holds bachelor and master degree in the information technology and the PhD in electronics and telecommunication engineering. He is associate professor at Techno International Newtown, Kolkata, a visiting fellow at University of Reading, UK, and the senior member of IEEE. Sir have published 300 plus research articles in reputed journal and conferences and have authored 40 books. His Google Scholar profile, which is having 25 plus citation, H index of 79 and I-10 index of 475, highlights his significant research contribution. Dr. Day also served as the committee member in the prestigious international conferences and the journals of IEEE Spingers elsewhere and many more. Sir is also associated with IETE, IE, ISOC, etc. We are privileged to have him with us today to share his insights on the bigger, the better. Over to you, sir.
Yeah, good morning, ma'am. So I'm
Good
audible,
morning,
right?
sir. Yes, sir.
Thank you. Thank you. Just a minute. Let me share my screen. I'm audible and the screen is visible, right?
Yes, it's visible now.
Okay. Thank you. Good morning to all. So this is 20 minutes talk on a machine learning topic, the bigger, the better. So let's try to understand a very primitive, problem statement, the computation of pi. The pi value, it's we all know this 3.141592 and dot 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 etc. Now, some Swedish scientists in 2021 they tried to compute the decimal points of pi, and they used the so-called superpower, maybe so-called supercomputing, or also the big data, and they find out 62.8 trillion decimal points, and that took 108 days 9 hours. So you can imagine 62.8 trillion decimal points digits. And interestingly, from VIT Vellore, a student able to memorize all, it's a Guinness record also, the number of maximum decimal points. So you can search in web and you can find that is also a Guinness record. Now, how many numbers of decimal points actually we need in our day-to-day life? Just to compute the circumference of Earth, we need only 10 decimal points. Now, to compute the circumference of Milky Way, it needs only 32 decimal points. And if you look into the size of the observable universe, that is a Planck length. So Planck length also takes 65 decimal points. So we are actually able to compute 62.8 trillion decimal points. And now in reality, 65 decimal points is enough. Now, what about these remaining 62.79 trillions digit? The thought process is, are these scientifically useful, or simply we are just proving the superpower of computer and just generating the big data and they don't have any usage? So we need to think that whenever we are talking about big, it's always might not be better. So again, I am repeating, once we are talking about 62.88 trillion numbers, and the actually scientific contents which we required, that is not, more than zero point 0.1 trillion numbers. So 62.779 trillion numbers is nothing but theoretically, you can say scientifically of no use. So we need to revisit the question, the bigger, the better. So whenever we are talking about the bigger, it might not be always better. So that is the first question. Now, talking about the world all data paradigm, if you see the whole data space, you will see we are talking about 90% data are unstructured data which never analyze. So nobody opened that data. Say maybe phone call records, maybe the customer review, maybe the customer complaints. These all are so-called massive data, which is so-called dark data. So 90% of the data are unstructured data which never opened. So nobody knows that data is good data or bad data. So this so-called dark data is nothing but digital pollution. So whenever we are talking about data, and data, we need to think that data is a dark data. They have scientific value. They are good data or they are bad data, or they are simply data pollution. So it's a kind of, it's the wastage, which you can say it's a digital waste, nothing else. So that's why uh, machine learning algorithms, we all know that intrinsic nature is the hungriness of the data. So if you feed more and more data, it will come up more generalized formation. So maybe it very much depends on the or sensitive to the data which you are actually training using for the training purpose. Now, if you're feeding more and more garbage, automatically the output will be garbage. So we need to, I mean, whenever we are using some data, whenever we are feeding some data, we need to think about it that it's not about only big data, rather it should be good data. Now, talking about the first process, whenever you are feeding the data, that need to be passed through a proper cleaning mechanism. So cleaning mechanism means it will clean the badness of the data. So what are the different badness of the data? The data can be inconsistent schema, the data can be redundant data, the data can be missing value, the data can be contextual error, garbage value, etc., etc. But for all these badness, to clean the badness, there are some certain algorithms, some certain procedures, some certain methods are there to clean the data. But still now, there is not a single generic framework. If you feed through that generic framework, it will clean the data. So the thing is, I mean, still now we don't have on one algorithm, single algorithm, which can clean the data. Any type of badness can be cleaned. No. So for depending upon the badness, the cleaning process will differ. So that is the interesting thing. All good data are look alike, but bad data in their own way. So all the different badness are different. So there is no single algorithm which can clean the data, but we need a cleaning procedure. We need to pass the whole data set before the training of the data. So there should be a cleaning mechanism which will clean all the badness. So we need to understand what type of badness is there and which particular algorithm can be deployed to to clean the data. Now, this is another question. Now, how much data you require for machine learning? I mean, there is no heuristic strategy or even meta heuristic strategy also, which can decide on which can tell you that this much amount of data you required for this particular application. So there is no hard and fast rule. Now, once we talk about this garbage in, garbage out, think about the LLMs. These all LLMs, if you are feeding without cleaning the data, simply you are feeding the garbage, automatically the output will be garbage. Even though RAG applications, if you go for, you will see it directly impact the quality of the generated outcome. So that is another concerning part. Now, once we talk about deep learning is nothing but a memorization technique. So it's a kind of model of interpolation. But the main issue of neural network, even the deep learning also, the absence of relationship, understanding the relationship in between the data. So it failed to understand the interlinked relationship in between the data points. So that's why we need to train our model with lots of variable data. So if the two limited the capability of understanding the underlying relationship in between the data, what you need to do, you need to train your model with lot of variable data. Just to overcome this, we have to covering all the aspects. So the cameraman should not take a single photo from front face of the Taj Mahal. I mean, he should take all, 360-degree photos so that there will be a lot of variable data which will be trained, used for the training purpose. So that's why it's not about big data. Okay, so it's not about the big data. It's not about the big clean data. It's rather all about the big clean and variable data. So we should think in a different way. So it's not about what we are feeding to the machine learning models. Rather, whenever we are feeding the data, Even the data is a big data, so-called big data, we need to think, is the data is a clean data? Is the data is variable data? If the data is clean and variable and big, then it is good for machine learning. Now, interestingly, we invest more and more time for, benchmarking data, the labeling of the data, the kind of creation of the ground truth. So there should be a trade-off in between the invested money and invested time, because you are maybe sometimes you are spending too much of time for the labeling, or maybe you are spending too much of time for labeling. So there should be a balance in between this. It's always good to come up with a proper, benchmark data. It's good to invest time and money for this, but there should be a trade-off in between these two. And talking about a little bit of history. Now, ImageNet is a database which you all know. In 2009, Professor Lee from Stanford University, they come up with a huge data set, which is called a ImageNet data set of 14 million data. So 14 million hand annotated data with 80,000 distinct category. Now think about it, 80,000 distinct category and 14 million hand annotated data. Now, during the period of shallow machine learning before 2012, the error rate was 26%. And gradually, once AlexNet introduced in 2012, it's deep 10%. So it is becoming 16%. Now, once it moved to ResNet in 2015, it is lesser than the human error rate. So human can make mistake to identify 80,000 distinct category from 14 million data, but ResNet not able to, it will actually able to do the thing. So we are in that era. So I'm talking about 10 years back in 2015. Now every year this competition is going on, and every year these numbers are getting down and down. So we need to think about this, how much complex these deep learning models are. Professor Hilton in 2012, he reported one interesting work. He said that if there is 9-layer convolution neural network, only 9 layer, and 60 million parameters, 6.5 lakhs intermediate nodes you required just to get, 1000 category. For 1000 categorization, you need 60 million parameter tuning and 6.5 lakhs intermediate node. So think about it. If I'm talking about 80,000 categorization, what will be the complexity of the whole model? How many numbers of parameters and how many numbers of intermediate nodes you require? So that's why parameter tuning is very important for any deep learning framework. And the number of parameter, if it is increased in such a way, then it is very difficult to control. So without knowing this philosophy, if simply two deep learning models, if we try to come up with a hybrid model, that actually might be give you a little bit of improved result, but ultimately we'll see the complexity is getting much more higher. So that's why we need to always think from the complexity point of view of deep learning models, that it should not be very simplified. It's okay if even we know it's not very simplified, but when we try to make, say, hybrid models, that sometimes it is getting too much complex. Because this is an example where you can see that 1,000 categorization, forget about 80,000 categorization, only 1,000 categorization requires 60 million parameter tuning, which is huge. So 80,000 categorization for this vision computation, competition is, it's an enormous. So that's why this is another challenge. Now talking about one of the very primitive, another algorithm of deep learning from the very beginning, we know convolution neural network. See, convolution neural network, there is an interesting point, which is called the function is called the pooling. So once we're talking about the pooling, simply we are, finding out the max pool or the mean pool, and we are throwing remaining pixels. So what we are doing, without understanding the underlying relationship in between the data, we are simply finding out the mean value or maybe the max value, and we are throwing remaining discarding all the pixel value. But think in a different way, which you are throwing, maybe 3 cross 3 9 matrix, one value you are actually passing to the next layer, and remaining 8 value you are throwing, you are simply discarding. Amongst those 8 value might be some value can be a better value or good value in future. But without knowing that thing, we are simply discarding blindly. So pooling is nothing but one of the biggest mistake of, convolution neural network. It's not actually, this is quoted by Professor Hilton in a AAAI conference, he mentioned that pooling operation used in convolution neural network is a biggest mistake, big mistake. And in fact, that is works so well is a disaster. I mean, maybe convolution neural network works very nice, many cases, but pooling is a kind of such kind of disaster where one pixel, if you simply take and remaining pixel you discard without knowing the underlying relationship in between the data, might be you are actually ignoring or overlooking the power of those discarded pixel values. Now, in machine learning, the main challenge is there are different cases. Say, for example, in medical imaging, or maybe say one people who is working on some very sensitive data, data annotation is the biggest issue. Because see, for example, in medical science, the doctors are so busy, clinical experts, they don't have time to come up with the benchmark data or the ground truth data. Manual annotation of this data is very time consuming. But until you have manual annotation, you can't compare your algorithm, how good your algorithm is or how bad your algorithm is. For different countries, they have their own data privacy protection law. There are a lot of legal issue, ethical issue. So that's why collecting of data is the biggest challenge for many of the cases. Say, for example, in medical imaging, maybe if you are dealing with 100 CT images or 500 X-ray images, I mean, you can see it's a 500 subjects. And other side, the same deep framework you are using on 14 million data. So data is important, but gathering of data is sometimes very difficult. So this is one point where the data, getting data and generating the annotated data is a very challenging kind of task. One of the solution can be if you have very less size data, I mean, the ground truth, the annotation data, you need not to go for say supervised learning or unsupervised learning. In between, there can be a weekly supervised learning. So weekly supervised learning means, I mean, if there is a non-expert, maybe some engineer who is actually trying to annotate the data for you as a doctor. So you know that there should be some, I mean, error. It's an intrinsic nature. It's a cheap annotation from the non-expert. Definitely the entire model should have some bias. I mean, some error. So considering that error might be if you are trying to come up with a, say, annote technique, that is a kind of low quality annotation, which is a kind of uses of the weekly supervised learning. So it's better than the unsupervised framework, but obviously it's not too good like supervised framework. There are a lot of heuristic mechanism also, which actually creates that annotation for you. So this is one solution by which you can create your ground truth data. So you're taking help of a non-expert who is actually don't have that much of expertise in this particular area. So you know that there should be some delta error, but you can taking a support from that guy so that you can come up with a non-expert annotation support. So for weekly supervised learning strategy. Now, the issue is once a data is a very small size data, then this is a kind of, it's not about talking about the big clean variable data. We are talking about very small size data. Say if the data size is say 50, if the data size is 100. Now, what happens with this? There are a lot of cases where the availability of the data is a big issue. And for that, how machine learning actually works. Because the problem is if the data size is 50, it's mainly revolve around a high variance. There is a very common case, there can be overfitting case. And in 50 data, if there is outlier, if 5,000 data, there is outlier, the 50 data outlier is something dangerous. So how to deal with small size data problems in machine learning is again a very open challenging problem. If the data size is large, machine learning algorithms say a point interpolation, maybe come up with a generic, say any kind of decision making process is much more easier. But if the data availability is very less, how these machine learning models actually work? So that need to be investigated properly. Now, one solution of if the data set is less is the synthetic data. Now, in synthetic data nowadays, everybody is talking about synthetic data. Now, I mean, every year, if you look into the graph, you will see by 30 might be the generation of synthetic data will be much more higher than the realistic data, actual data. Now, what's positive side of synthetic data? The positive side of synthetic data is once you create the synthetic data, there is no legal issue, there is no privacy, copyright, ethical issue. So you can use the data without taking any kind of consent. So that is good point. So, I mean, if you're dealing with some photography, which is created by some synthetic data as a synthetic data, I mean, you need not to go for any kind of say, I mean, this kind of phases, this privacy concern, or maybe the ethical issues are there, nothing like that. So that is good part. So it's in real, it's not real data. It's very close to the real data. The process is time consuming, sometimes costly, sometimes it's very impossible to create the original, very close to the synthetic data. But this culture actually, it's not very new. If you look, say, 4 5 years back, when people actually started working on GAN, and nowadays, once we are talking about those LLMs or those GPTs, this generative AI framework helped that time also to create the synthetic data. So synthetic data is a future of machine learning. That is our biggest another question. Means, I mean, in future, might be we are talking about more and more synthetic data. So maybe it's hard to distinguish which data is real data and which data is synthetic data. So this might be a future of machine learning. Now, once we try to create more and more synthetic data, one of the oldest technique is the data augmentation technique. So geometric transformation. So we create take the original image, we rotate, we translate, we flip, zoom in, zoom out, stretch in. So these are the techniques. Maybe elastic deformation, maybe contrast stretching, maybe color augmentation, sometimes random cropping, sometimes mixing images. But if you look this last one carefully, you will see the Gaussian blur, the change of the variance level. If you change the variance level, the image is getting many different images. So one image you create by, say, kernel filtering lot of different images. But the problem is, whenever you look into any images, you will see that is somehow basically created from the basic image, the fundamental image, the first image. So whenever it is, all these images are created from the first image, that means it's nothing but redundant data propagation. So that means somehow these processes are biased. So even though people are still using this kind of method for data augmentation, but these processes are somehow biased. So that's why we need some certain other solution. So one of the solution is maybe a transfer learning model. So in the transfer learning model, if the data size is very small, you have failed to solve that problem. You try to solve this same similar kind of problem where the data size is large. And then you pass that knowledge as a frozen knowledge to solve a problem called B. So if you are trying to solve a problem called B, where the data size is less, you try to solve a problem called A. And if the size of the data set in A is huge, you solve that problem, gathered that the knowledge, you pass that knowledge as a frozen knowledge or the pre-trained knowledge, and then you solve the problem statement B. So that is the fundamentals of pre-trained model, or the say so-called transfer learning models. And this is also a kind of, you can say, somehow if you're dealing with such kind of model, the interesting point is based on which data set you are trying to transfer the model. Maybe you are using ImageNet data set. Now ImageNet data set, even though there are 14 million data, but all data are good data. They are taken from a proper lighting condition, proper shape. See, if you look into this chair, all chairs are so-called good-looking chairs. But in reality, chairs are something different. The room are messy. So we never train those data set with those kind of bad data. We only consider good data. So that's why ImageNet are also having some fundamental flaws, because only consisting the good data, it never explored that essence of the bad data. So that's why once you are going for transfer learning, you need to think from which particular data set we are passing that knowledge, and that data set is a good data or it's also having bad data. So this is need to be investigated. And then comes the robustness. One pixel if you remove on aeroplane can be a dog. One pixel if you remove a frog can be a dog. So this is called one pixel attack. It's an interesting paper published few years back in TEC, where the authors reported that only one pixel can make it full. So that's why deep learning systems are quite good at large fraction of a given domain, but it can still easily fool. And lastly, once we talk about this trust issue, we all know nowadays people are always talking about the explainable AI, the explainability and the performance. So if the rule-based model or the linear model, the explainability is very, high, performance is low. If you move to hidden Markov, if you move to say support vector machine, say XGB or maybe the random forest and then CNN, you will see the performance is getting improved and improved, the explainability will be lesser. So why should I trust this model? But see, think the last point is very important. XAI models are always focused into the model. They try to explain the behavior of the model, but they never try to explain the behavior of the training data set. So nowadays, up to now, I mean, whatever the XAI models are there, say every time you will see they are talking about the behavior of the AI models. Nobody actually talking about the training data. So data quality is very important. So quality of the input data actually helps to make the decision. So once we are talking about the explainability, we should also consider the quality of the data, the inherent biasness of the data. These things are still, there is a missing part. And lastly, once you talk about the explainability, you also think in a different way. We always try to explain the big data models. But if the data size is very small, how to explain that models? That is also another open challenging area where some people are working, but there are huge part where people can work. Like if the machine learning models are actually dealing with very small size data, how XAI model performs. And once we talk about this LLMs and all, the interesting another point is every time you think in a different way that we are not talking about time consumption, I mean, complexity or not, today nowadays we are not talking about the space complexity. Rather, we are talking about more and more energy consumption. So how much carbon footprint, if the LLM models are using, how much carbon is emitting. So even though deep learning models, the complexity can needs to be measured by carbon emission, because once you are trying to reach the sustainable goal in maybe 2030, then our target should be to come up with some AI model where the carbon emission will be very, very less. So how to optimize this framework so that the carbon emission will be less. And lastly, what's in the future? Maybe the AI future might not be with the large size data, might be small size data, and definitely human in a loop machine learning. So human intervention and expertise you can't ignore. So human intervention should be there. And how fake data is real enough means we need to find out, we need to think somewhere, we need to stop, because synthetic generation, data generation is fine up to a certain level, but after that, I mean, if you create more and more and more realistic data, maybe someday you need to think real is real enough, how real is real enough. And lastly, the I mean, we always think about machine learning. We also need to think about the unlearning process, because if there are many cases where people are sharing their data now, maybe after 10 years down the line, they are reclaiming that data. They are asking back their data. So once because maybe personal issue, privacy, legal issue, anything. So now think about it. If you have data, you are trained your model now, after 10 years, some people ask to roll back their data. So will you retrain the whole model? No. Again, so if you are discarding few data, then the model should work as it is. So that is the phenomena of how it works for the machine unlearning models. Though there is a lot of scope to work in machine unlearning, where if you even if you exclude the data, forget the data, then how these machine learning models work, I mean, same way, that needs to be investigated. Thank you very much. So if you have any query, I mean, you may ask.
Thank you so much, sir, for your insightful session.
Thank you, ma'am.
Uh, Amit Joshi, sir, am I audible to you? Amit, sir? Dear participant, please hold for a few minutes as expert is having some glitches in connecting the session. Joao sir, am I audible to you? Hello.
Yes.
Sir, due to some glitches at the another expert end, can we shift your session for now? If you are okay to start for now.
Sure. If you want to start earlier, it's okay for me.
Okay, sir.
So let me just prepare myself.
Sorry for inconvenience. Due to some technical issues, Amit sir will joining afterwards. So let us start with the session of Dr. Joao Soares. Uh, Dr. Joao holds a doctorate degree in the electrical and communication engineering, and he is associated with JECAD, a research group of Polytechnic of Porto, Portugal, and uh, so Lille School of Center at the France. With over 200 plus research publication, he was recognized among top 2% scientists in 2021 list generated by the Elsevier EV United States. His research impact is influenced in 5,000 plus citation, H index of 41 and the I-10 index of 102. His research expertise lies in power system and computational intelligence. Additionally, Sir served as a chair for the IEEE ISATC task force. We are honored to have him, sir. Over to you, sir.
Thank you for introducing me, and thank you so much for the invitation. I will share now my screen to see if it is working. Can you verify? Wait, switch displays. Can you verify if it's working?
Yes, sir, it's working now.
You can see? All right. So without further ado, my talk will be on evolutionary computation for complex energy problems. Just to check if you are listening well or not. Hope so.
Yes, it's working.
Okay, great. So my talk will be on this topic. I will introduce the motivation for my talk, then what is optimization and what is complex for optimization in energy field, in power systems. Then a bit on evolutionary computation, what is EC, what is the accepted scientific approach for using EC and some energy applications before going to final thoughts. Why I have been using evolutionary computation and why I think it is important for future engineers and future scientists in this field is because our energy grid has been suffering many changes in the last 2 decades. In the past, more than 50 years ago, we were used to a system where the grid was having its consumer further apart from the energy production centers. So we had big energy facilities producing power and then transmitting this power across many kilometers, many miles to city centers. But with the increasing of renewable and centralized generation, and with the new technologies related to smart grid applications and new communication technologies, we are going forward here, where we'll have many storage systems, many electrical close to energy consumers. So this is a shift and a new paradigm that will require closer monitoring and closer daily operation, and optimization will be required on the daily basis. In the past, we have to dispatch our energy, we need less optimization, and now we need constant and decentralized optimization, or some local optimization that is centralized in some way, but will require a much more complex daily operation. And it is in this sense that evolutionary computation will be used. For those that do not know what is very well optimization, basically is when we are talking about minimizing or maximizing one or more objective functions. So if you are, for example, making a decision investment for the energy grid, where to install new batteries or new electric vehicle charging stations, or where installing or minimizing some operation costs, you will be subject to some constraints, like the budget of your investment. You have a limit, and some technical and more financial constraints. So you are in the presence of an optimization. So you need to decide some variables, either continuous or binaries, 0 or 1, and you need to find this point where you want to minimize your function. Um, but these problems can become very complex depending on the type of the energy problem you are solving. You can identify if your problem is complex or not. For example, if you have a high number of variables, either integer or continuous, or integer and continuous, this will be even more complicated. So if you have a high number of variables, most certainly you are in the presence of a very complex problem. Usually this happens when you're doing centralized energy scheduling, because you are centralizing all the resource, so you will have a large number of variables, optimal power flow of very large networks. When you consider uncertainty, because you have a large number of scenarios to account for the uncertainty. Also, it can be complex because you might have some limited decision time. So when you have some limited decision time, this can worsen your complexity, because if you have to decide under 24 hours, like a day ahead problem, then you need a quick solution. Or even worse, if you are in an online network reconfiguration problem, you have 5 minutes, then you still need even a more quicker solution. Other way to have complexity is when you have nonlinear objective function or nonlinear constraints. For example, when you have two variables multiplying by themselves in your mathematical problem, then you have a nonlinearity. This can happen also when you have nonlinear functions like the full AC power flow equations. Sometimes you have to linearize them. Nonlinear generator cost functions, polynomial of second order, and so on. Uncertainties in our energy problems have been tackled in many different ways. You will find some nice literature on that. For example, this one that tells you how you can model some uncertainty for different components of loads can be modeled as a normal Gaussian distribution. PV power can be modeled with the beta distribution or Weibull. For winds, and then electric vehicle demands can be also modeled by a Gaussian distribution. For charging departure times can be modeled with an exponential, and for customer arrival times can be modeled with Poisson. So you have different ways where you can model your uncertainties, but this will have complexity because you will have different possibilities and different scenarios that you need to account in your mathematical model. So instead of one instance, we'll have like a mirror of instance to account for different possibilities that can happen. And that's here when you face the complexity of the problem, you have to look into the perspective. If you are in the presence of a complex problem with the characteristics I just told you, then you probably will need evolutionary computation. Obviously, if you have a very simple mathematical problem with very few variables, 10 variables, 20 variables, perhaps if you don't have complexity, you don't need evolutionary computation. So you don't need to use the cannon to kill the fly. This is a Confucius saying. So you have to adapt to the circumstance. So we come to what is evolutionary computation. In fact, evolutionary computation is a subset of a broader topic, a broader the computational intelligence, as they say. And computational intelligence is a set of different methods that also includes machine learning and so on. That usually is recognized as a family of problem solving, problem stating methods that will mimic the intelligence observed in the nature. So when we talk about this kind of methods, usually they are based on some nature behavior. They replicate some intelligence that you will see in the nature. And these methods are a bit separate from AI. They are sometimes related to AI. For example, machine learning is related to AI, but they are more related to soft computing rather than hard computing, because in AI, poor AI, they try to have the hard computing techniques and the theory behind. In CI, we have intelligent computational tools that we try to solve and model complex problems. And evolutionary computation is part of CI, and it's a subset of AI. So some years ago, I did a survey, a review paper, and tried to understand how evolutionary computation was performing in the energy domain. There are an increasing number of publications since 2000, at least until 2016, and 10% of the publications I found related to CI were already from energy applications. So among around 25,000 publications, almost 10,000 were, sorry, almost 2,600, 10% were related to energy applications. And there is a noticeable trend among other areas like neural networks, machine learning methods, and fuzzy systems. You can see this curve that you see that evolutionary computation is gaining some importance compared to fuzzy systems and compared to neural networks. Basically, when you talk about evolutionary computation, we have one tool that is the meteoristics, and meteoristics can be divided also in different categories. You will have evolutionary algorithms that I don't have time to go into any of for details of them, but I can, for example, explain evolutionary algorithms. But you will have evolutionary algorithms like genetic algorithms, differential evolution, swarm intelligence, like the particle swarm optimization method. It is non-human related. Then you have the human related swarm intelligence. And you also have physics chemistry based, like the gravitational search algorithm, harmony search, and many others. These are population based, where you will have more than one individual in the population. And then you also have meteoristics that are only one individual, like the large neighborhood search, simulated annealing, variable neighborhood search. There is a good paper from Sungatan that tries to to list most of the meteoristics existing. There are more than 500 at least out there. The most relevant are genetic algorithms, differential evolution, particle swarm optimization, and so on, with number of applications. If you go to this article, you will see a very interesting study with more than 500 nature-inspired algorithms. And I told you I can explain a bit on how they work. For example, going to evolutionary algorithms. Basically, this is a generalized framework on how evolutionary algorithms work. As I told you, is a population-based algorithm, and in population-based algorithms, you will have in all of them, you will have some sort of recombinations, so mutation and selection after you do these steps. So usually you select some individuals from the population to make crossover operations, so they will switch information. Imagine you have 10 individuals in the population, you will select two of them attend each before searching all of them. You will do some recombination between them, so switching some information between these two, like switching information of variable status and so on for a problem. Then you do, after recombination, you do some kind of mutation. In nature, you also see that. So you see some mutations. Some are good, some unfortunately are not. But we introduce this kind of mutation to after recombination. And then we evaluate if these mutations and the recombinations are good for the new child. If they are good, we select the promising candidates and so on. And this is a loop that goes on until we find a better solution. At our lab, we have been developing some meteoristics, and if you are interested, we have developed an adaptive version from differential evolution. Okay, so you can download it. We have been ranked very well in a competition of CC and GECO in 2009. We were third among 38 algorithms. And we have been using this method in many publications. The idea of this method is to go from a global exploration phase where the algorithm is searching for many different solutions in the search space. And then as the times goes on, we switch to another operator, another operator that is more local operator, and this operator will search for more local solutions, so a local exploitation stage. So we have this algorithm described in this publication here. I invite you, if you want to, you can download it with this QR code. Yeah, I invite you to go to the website and you can download the source code of this algorithm and try to see if it works well for your energy problem or any other problem you can face in optimization. I told you that we need a scientific approach when using evolutionary computation methods. For example, I showed you eyes, but sometimes it's not enough. It's good that we use more than one when we are trying to come up with a solution for the energy problem. So it's important that we evaluate the fitness value, obviously, but also take into account the execution time of the algorithm, the number of function evaluations, all right? So if you are comparing two different meteoristics, the number of function evaluations you compare should be the same. So take into account that. Never make a comparison in when one is have more advantage in the number of fitness function evaluation, because that will not be fair. And the number of fitness evaluations is not the same sometimes as the number of generations in the algorithm, because depending on the algorithm and the number of individuals in each algorithm, the generation might be 20 evaluations, other algorithm might be 20. So at the end, you should know how many function evaluations you are doing, and you should compare them using the same number, okay? Also, some sort of statistical test validation. For example, Wilcoxon signal rank test with some level of confidence to give you an idea on how many, on how reliable these trials tests have been. At least 50, 100 trials is good, but depends on the complexity of your problem. You need to have time to do the experiments. I recommend this paper where it shows you on how to use statistical tests for comparing evolutionary computation algorithms and also swarm. So it's a good, very good article for that. So now I will show you some applications where we have used evolutionary computation for energy problems with some success. For example, I don't have much time, but I will try to be quick. We have energy scheduling problems where we have a network with many energy resources, different distributed generation units, PV, and so on. And you are trying to do this scheduling of resource for the next day. They had, and we have 1,800 electric vehicles with vehicle-to-grid function. Here, if we use a pure mathematical method, accounting for the full AC constraints, we'll have an objective value of 5,667, but the time is very high. It takes 14 hours. If we use a meteoristic, we have a less time, a less objective function, less profit here, but the time is reduced to just 10 minutes, so it's much faster. If we increase the problem size, like here, we are using a bigger network with 180 bus. The other network, I forgot to tell you, but it was only 33 buses, all right, including substation. If we use a bigger network with more resource, with more storage units and more electric vehicles, The same method, mathematical, takes now 13 days. So the time increase is exponential. If we use a meteoristic, we still have some reduction in the objective function, but we can solve it in the satisfactory time, the time we need. So we can solve it in half an hour to 1 hour, depending on the meteoristic we use. So just to give you an idea on how these methods can help to achieve quicker solutions and still satisfactory solutions within reasonable time. Here I want to show you how in a similar problem, but including uncertainty and risk in the objective function, I want to show you how different meteoristics might perform in your problem. So that's why you cannot rely only in one. For example, here we are minimizing the cost in this case, and obviously the lower the better. Here you can see that different meteoristics produce different results. For example, shade and L shade, they are not very good in this problem. This one looks better, height and vortex surge. So you see that they can find better solution than the other methods. And even after 500 generations, it seems it has not stopped because you can see clearly that this is still trying to go and not stabilizing. So just to show you, we run until 5,000, so increase it 10 times. And you see that it has not stopped at 500. 500 was here, and it keep going. You know, here 500 was 40,000 here. So around here was 40,000, right? You see this value, and you can see that it keep going. It keep going, and he achieved almost 15,000. So you cannot rely on only one algorithm. If you choose this one, it will stop here. In here is very, very bad solution. You need to use more than one, and sometimes you will see that some methods perform better than others depending on your problem. We also have been developing one tool. We hope we can make this tool available. I think it's not working. I wanted to show you, but unfortunately, it seems not working. So sorry for that. But we have been developing this tool that we want to make it available for everyone. And in this tool, we will have different energy applications. Let me just see if I can run it. Yeah. This tool will allow different energy researchers and professors to explain to students our studies that we have been developing. For example, the 33 bus case with 118, 1,800 EVs. So this case I just showed you, we have in the database. We can choose different meteoristics here, you see. Between PSO or differential evolution, and then we run it with different parameters, different population, different parameters of the meteoristic in this file. And we can run the simulation. After we run the simulation, we can see the result, and we have different parameters. You can see the convergence, if it has run well or not, and some results for the energy problem, like the generation, the consumption, and the time, and the fitness function, and so on. So the idea of this tool is to make it available soon. I also invite you, if you like, well, energy problems in this field. We have been running many competitions along the years since 2017. We already have run 9 editions. The first one was in Power and Energy Society General Meeting that happened in Chicago. But since then, we have been running many competitions in different conferences. This year it's happening in SSCI 2025. We call it Winter Edition. It will be in Norway, and the Summer Edition. You can still try to compete. and it will be in CC Geeko, so the QR code that links to the web page. If you just search Smart Grid competition, JCAD, you will find the website and you will find all the problems and test beds that we have been running in these competitions. Just some final thoughts about this. So the computational intelligence is a growing field in the energy domain. I showed you some trends from a study a while ago, but evolutionary computation was among the methods that were gaining track even among machine learning and other and physics systems. And obviously, the characteristic of complex in the energy problems needs to be well thought. So the application of EC is only suitable when you are facing complexity. When you are not facing complexity, you will not probably need this. You can still rely on the traditional methods that they are efficient, but metrics will be justified when they fail, okay? And to use these methods, you need an adequate scientific approach. I suggest to rely on more than one. It is impossible to test all. There are many. As you see this paper from Sungatan, it's more than 500. And you have to use statistical tools to compare the performance, different number of trials, more than 50 at least, 100, depending on your method, on your problem. And you have to rely on these tests to be sure that you are saying this one is better than another for this case, this energy problem. So this is very important to take into mind. This is also applied to beyond the energy problems, so to communication and other IT problems is also applicable. This, okay. If you are interested in the computational intelligence for the energy domain, I am the chair of this IEEE task force. Just contact me. Perhaps you can contribute with your knowledge, even from other fields, uh, for our task force. It was established in 2014. I'm co-sharing it with Fernando Lezama. Okay, so if you can contribute, let me know. I have here some publications that might be worth for you to take a look from our group. And a note about me, I have a computer science background and energy PhD. I have some projects related to energy domain and some experience, as I told you. So if you are interested to collaborate, just send me an email and we'll keep in touch. Thank you so much, and thank you the organization for having invited me. It is really a pleasure to make this speech from Portugal. Thank you.
Thank you so much, sir. It's pleasure to have you with us and sharing your insightful knowledge related to the topic.
Thank you. Thank you.
We have next speaker with us, Mr. Amit Joshi. Am I audible to you, sir?
Yes, you are audible.
Okay. Uh, Let us welcome Dr. Amit Joshi. Sir holds undergraduate, postgraduate, and the PhD degree in the Electronics and Communication Engineering. He is currently an associate professor at MNIT Jaipur and the senior member of IEEE. With over 125 plus research article and the 3 patents on his name, Dr. Joshi has made significant contribution to the field of biomedical signal processing, smart healthcare, VLSI system, embedded system design. His research influence is demonstrated by 2000 plus citation, H index 26 and the I10 index 64 shown in the Google Scholar profile. He is actively involved in the prestigious international conferences, including ISES, ICCE, ISVLSI, and VDAT as committee member. Additionally, he is associated with IETE. We are honored to have you, sir. Over to you, sir.
Thank you, ma'am, for such a nice introduction. May I share it? But I'm not able to share it right now. I think sir has to
Sir,
stop.
I'll stop talking. Can you share now?
I'm not able to allow tab.com to see your screen. It's not able to. I'm not able to share. Not sure.
Sir, can we do one thing? I'll share your PPT.
Yeah.
You just let me know when to change the slide.
Yes. That's why I thought that maybe there could be an issue. Okay, you can share your my slide. Yeah, definitely.
Is it visible now, sir?
Yes. It is pretty much visible. Okay.
Okay, sir.
Okay. So thank you all of you for joining this session. So I believe that the one of the theme of this particular conference is a smart city. Okay. So possibly means I will be discussing one of the very relevant topic for this particular conference, which is smart healthcare technology. Okay. So where I will talk about some of the healthcare technology, and I will list down some of the opportunities and challenges which are there currently, where maybe if you want to focus on your research, then you can do it. Please next slide, ma'am. So these are the content that I will talk about the smart healthcare. Then I will talk about the variable technology, then emerging application, and finally I will talk about the challenges. Okay. Next slide, please, ma'am. Okay. So before try to understand a smart healthcare, possibly we need to first understand about the traditional healthcare. Okay. And then why it is needed to have a smart healthcare mechanism. Okay. So when we consider a traditional healthcare system, then possibly it is very decentralized one. Okay. And most of the thing, most of the time you need to do the many things at the manual way. Okay. But in a smart healthcare, what we want that there has to be some sort of centralized system, okay, where each and individual stakeholder will talk with each other with some sort of intelligence, okay, so that as a patient I can get some value added service out of it. Okay. So next slide, please, ma'am. So why smart healthcare is important? Okay. So basically in a smart healthcare, the IoT play a very crucial role. Okay. So where you have so many things which are there, when I consider things, then possibly in a smart healthcare, we are talking about the variable sensors, okay, which generate the data, and that data is basically generated from a different patient that we term as a people over here. And then we will apply some sort of process which we consider as an algorithm to uh, get some useful information out of it. Okay. By doing so, we can get in a smart healthcare to have some sort of treatment and health conditioning monitoring, which actually help us to have early diagnosis and as well as to apply some sort of preventive action. Okay. So ultimately, smart healthcare will help you to have a continuous health monitoring, which is very important. Some sort of healthcare automation. So ultimately, diagnosis of problem is not a, you can consider the full solution. Okay. In a smart healthcare, possibly I would like to provide some sort of point of care mechanism also. Then it could be some sort of drug delivery mechanism and preventive healthcare. Okay. Next slide, please. So when I use a IoT concept in a smart healthcare, okay, or in a healthcare domain, then I used to term them is a medical internet of things or internet of medical things. Okay, where here we used to collect the data from a variable sensor. Okay, and then we can transmit the data to a cloud. Okay, where maybe your algorithm will run, and through the help of the cloud computing, you can derive some useful information. Or it could be a case that you have an edge processor where the data is being collected over there only. You are doing some sort of process, and then you are whatever the final decision that you are uploading at the cloud. Now, this IoT network could be very useful for a tracking and preventing a chronic illness. Now, what I mean by chronic illness are those illness which gradually occur inside your body. Okay, so it is something like that. If I say diabetes, then diabetes where you have a high blood glucose value, so that gradually happens inside the body. Even when we talk about the cancer, then cancer is also the same case. Okay, it has a different stages. So if you can do early diagnosis, now how you can do early diagnosis? Definitely with the help of a continuous monitoring, you can do that. So that can be possible with the help of the IOMT or MIOT network. Next slide, please. Okay, now basically when we talk about means any particular smart healthcare system, okay, so that is typically a cyber physical system, okay, where you have some sort of software, so you have some sort of hardware, and that basically combined with together to have some sort of value added service for a patient. Okay, whenever we use it in a healthcare domain, then we used to term them as a healthcare cyber physical system or medical cyber physical system. Okay, next slide, please. Okay, now what are the different features of the smart healthcare? Now, with the help of the smart healthcare, doctor and patient can meet with each other remotely. So definitely, means this is a one of the very good service, and particularly we have seen all of a COVID. Okay, at that time there was a certain restriction. Okay, so at that time maybe that is a way that through which the still patient can meet a doctor, especially in our country where we consider that there is a huge population and the number of doctors is very less. Okay, so at that time also means we can have a such kind of solution where the person who is sitting at the remote location can connect with the doctor and start early treatment. Continuous monitoring of the critical disease is possible. Corrective action and quality of the care with the proper diagnosis is possible in a smart healthcare. Real time access, okay, so it is something like that. Yeah, I can see or I can monitor or I can track the health parameter of my parents which are there at my home. Okay, even though I am at office from a remote location, I can virtually see that all the parameter of my parents who are residing at my home. So point of care service and medication could be possible with the some of the very intelligent consumer electronics device which are available in a smart healthcare. Next slide, please. Okay, now what are the different attributes of the smart healthcare? What we need to understand. Okay, so what we expect for a smart healthcare mechanism. Okay, so ultimately we want, of course, a very good sensing capability. So whatever the sensor that we are using, okay, which actually help us to get the physiological parameter of the body. So that sensor should be very accurate enough. Okay, see, we are talking about the healthcare domain. Okay, so over here the accuracy is a very paramount. Okay, it is very much critical because of that sensor reading only you are taking some sort of decision, and that actually deal with the life of the people. Okay, so here the sensing capability is very good. It should be also multifunctional. See, I want to capture as many parameter as I can capture from my body, but I do not want to wear that many sensor on my body. Okay, so possibly with a few sensor I can able to capture the as many parameter as possible. Then I would be definitely like to go for that. Obviously I want to go for a capturing of all those parameters throughout the day. Okay, even though I am sleeping but my body is working, so at that time also I would like to actually means collect the parameter. It should be always connected. Okay, and there should not be any location specific. Okay, so it should work in a all environmental condition. So that's what I expect that should have inside my smart healthcare system. Next slide, please, ma'am. Now we will discuss about the different component of the smart healthcare. Okay, how we can adapt it. Okay, so till now we have talked about the smart healthcare. Now the question is, if I want to adopt the smart healthcare mechanism, okay, in my daily life, then how I can actually do it. Okay, so we will discuss about some of the component out of that. So next slide, please. So e-health. So e-health is a one of the component where you use the internet or any kind of ICT technology that you use. Okay, currently means I am delivering a lecture online. So okay. So this is a one kind of ICT technology we are having right now. Okay, so whenever in a healthcare or for a medical purpose, I use ICT technology, then I can consider that as a e-health. Okay, so through e-health only, you can have a telemedicine concept. Okay, where doctor and patient can connect with each other. Okay, and one can easily get the prescription from a doctor by sitting at home only. Next slide, please. Now m-health is one of the very important component. Okay, and possibly one of the easiest component to be adapted. Now when we talk about the m-health, then whenever I use a mobile phone in a healthcare purpose, then I consider them as a M health. Okay. Now, mobile phone is one of the most convenient way that possibly we can have. Okay. And we can broadcast the message and we can easily reach through a mobile phone. Okay. Now, such kind of application has been used extensively. Okay. So it has been started in a 2014 crisis when UNICEF has developed one of the application as a M hero. Okay. uh, at that time of the Ebola crisis. Okay, so in the African region, they used to send some useful information for a public awareness over there. Okay, so that is the one of the application that from where the M Health has been started. Even we have also used the one of the very popular M Health application during the COVID. Okay, so that is the Arogya Setu. Okay, so through Arogya Setu, possibly you are booking your vaccination slot, you are getting vaccination certificate, or maybe you are able to identify that how many surrounding COVID infected patient. Okay. So that is the one of the application that we have used it. So that is the Arogya Setu. Okay. So there are so many applications currently are available which actually help us to maintain your lifestyle. Okay. That what could be your diet plan or it or how many steps you need to walk. Okay. So all these things could be possible with the help of the M Health component. Next slide, please. Okay. So rapid collection and sharing is possible with the help of the M Health application. So medication alert can be sent. So during the COVID also means we used to get the SMS that means your vaccination is about to means schedule. Okay, that second vaccination is you need to schedule it in a possibly next 1 week or like so. Okay, so that way means people have already used it. Okay, e-prescription is also possible. We already talk about the telemedicine concept. Okay, now currently the reports can be also easily available on a mobile phone. Okay, of course, when you want to go for a diagnosis or you want to go for a test, then you need to go physically for a sample giving. Okay, you need to in order to provide the sample to a laboratory, you need to physically visit, but not necessary that to get a report you need to visit the laboratory. Okay, so maybe through some sort of internet login at in the on the WhatsApp itself, you will be able to get the such kind of facility. Okay, next slide, please, ma'am. Now, connected health, which is a very important component. Okay, and possibly that is the biggest game changer in your healthcare industry. Now, in a connected health, what I want that every stockholder should talk with each other. Okay, so in the first slide itself, in a traditional healthcare mechanism, we have faced that all are playing an individual role, but they are not talking with each other. And most of the time, as a patient, I need to roam here and there as a carrier only. Okay, it is something like that. That if I am not feeling well, then I am visiting a doctor. Now, doctor will ask me to go for some sort of test. Then I will visit the laboratory. Then again, I will go to the doctor. Doctor will give me some sort of medicine. Then I will purchase the medicine from a shop. Okay. Now, if you think about this scenario, if somebody is not well, then everything should be available at your doorstep. Okay. If I am not feeling well, then possibly I should have a access of a medicine of a healthcare facility at my doorstep only. Okay, so that is possible in a connected health. Okay, now possibly in India, the government is planning to have a digital health ID of each and individual one. Okay, like we have a Aadhaar card. Okay, where you have all the identities being stored. Okay, so whenever you go for a bank account opening or anything, okay, which is related to a particular person identity, then Aadhaar card is possibly one of the way that through which one can verify. Similarly, in a healthcare domain, there will be a digital health ID for each and individual one. Okay, so through which what happens that all the health record will be stored over there. Now, whenever we consider the health record in a medical domain, then we consider that is an electronics health record, EHR. So that EHR will be stored over here and it will be permanently. Okay. So doctor will give the prescription maybe against that digital health ID. And if I visit a medical shop, then he already knows that what is the prescription or what is the medicine is being prescribed by a doctor. Okay. Because some of the medicine, in order to purchase, you require a prescription. Okay, And to be honest, that in India, we can purchase the medicine like allopathic medicine is easily available to be purchased at a medical shop. But in many countries, if you want to purchase a means medicine, allopathic medicine, then you should have a doctor prescription. Okay. So definitely with the connected health, this problem will be resolved. One of the biggest advantage with the connected health is the insurance settlement. Okay. Because in India, what is the scenario that if I want to claim my medical insurance, then I need to be admitted at a hospital, and I need to also inform my insurance agent. Okay, so that personally he can visit it, he can check my condition that whether I am being admitted, that is the true case or not, and then the settlement is being happen. But if this connected health mechanism is being exist, then it is very easy. Okay, that hospital has means provided the details against my digital ID that I have basically admitted for this particular disease and I have been discharged from this particular hospital. So automatically medical insurance can be settled by themselves only. Okay. So I no need to be a carrier in that case also, that I need to give the money to the hospital patient hospital agency first and then I need to claim it in a second step. Okay. They can directly settle down by themselves only. Okay. I need to just inform them. Okay. That I am being admitted. Now take care of rest thing. Now, that is the possible in a connected healthcare mechanism. Okay. So next slide, please. Now, consumer electronics are available in a healthcare domain. Okay, that which are available in a various form. That you have a smart cloth is there, smart belt is there, fitness tracker is there, smart watch is there, smart shoes are there. So all are there available. Okay. So we will be discussing briefly in variable technology. Next slide, please. So we will talk about the variable technology now. Next slide. So variable technology is a technology which worn by people. Okay, either at the cloth or as some sort of accessory. They will help to track our health regularly. Okay, it will help us to reduce the hospital visit and as well as avoid the readmission. Okay, so that is very important. Okay, so if I am being cured from one of the disease and I have been discharged from the hospital, then it is now responsibility of the hospital that it has to ensure that when a patient is being discharged, then he will not come back at least for a 2 month. Okay, and to be honest, that in US, that insurance company can sue that hospital. Okay, because that is the problem with the insurance company. That if I am claiming a medical claim, okay, for from an insurance company for the same disease, maybe in a month twice, then it is a problem for them. Okay, so definitely the readmission process can be avoided by having a primary healthcare checkup or tracking of the health parameter by having a variable technology. Okay, and such kind of technology is very popular after post-COVID area, because from COVID-19 itself we have more aware about now health. Okay, now we understand the some of the terms like immunity. Okay, so that actually help us to keep motivating for taking up my healthcare parameter regularly. Next slide, please. So what are the variable technologies which are people are using? Okay, fitness tracker and smartwatch. Possibly many of the participants or who is actually attending this lecture has having a smartwatch or fitness tracker. Okay, VR handset, virtual reality handset is also possible. Sleep tracker, smart clothing, smart eyewear, posture detection, and other variable technology. So most popular is the fitness tracker and smartwatches are there, which one can use it. Okay, next slide, please. Okay, so consumer market for the variable technology is increasing day by day. Okay, even the some of the big giants like Apple and Google are now focusing of the variable technology setup dedicatedly. Okay, so now they are also now concerning more about that that this is the upcoming technology. Okay, and possibly the more and more future is lying in that particular technology for the consumers. Next slide, please. Okay, now such kind of variable technology will be helpful for a different purpose. Chronic care. Okay, we already talk about the chronic illness. The person who is suffering from any chronic illness can be a end user of variable technology. Similarly, for the preventive health care, acute care mechanism, emergency care. So all are other purpose where you can use a smart variable device. Next slide, please. Okay, now what are the benefits of variable technology along with the IoT that you will provide. So real-time health monitoring we already talked about. It will allow us to send the alarm and alerts for a vulnerable presence. The patient physical information sharing is also possible. Okay, so specifically for the old age people, such kind of technology is very useful. If I want to locate that where my grandparents is currently, okay, so I can adopt such kind of technology. Social media sharing is also possible. Okay, so currently it is very famous that if I have draw a cycle for maybe half an hour, then possibly I can easily share that. And if I walk, let's say 2 kilometers or 3 kilometers in a day, or if I have completed 10,000 steps, then people do sharing on a social media. Okay, so that is also one of the easy way, and that you can consider as a motivation also. If somebody is a attention seeker, then he used to post that every information onto a social media. So that is also possible with the help of the smart variable technology. Next slide, please. So what are the different pros and cons? Okay, so of course we can go for a monitoring of the fitness level and we can track our location. It is hands-free and portable. So what is the good thing about the variable technology? That I can perform my daily activity and still the important parameter I can capture. Okay, till now most of the time that when you are being admitted at ICU, then possibly some of the critical parameter is being monitored. Okay, but now with the help of the smart variable technology, the everything is possible. Okay, with your simple variable device only. It is connected to the smart device, so you can actually view them later. Okay, so if I am doing my daily activity and I am unable to track my parameter, but they are being stored at the cloud, so maybe at the end of the day I can actually view them. Not at the end of the day, it could be a case that I am managing a diabetes, okay, and I am having some medication. Okay, now I want to know that before 15 days, whatever my glucose level is there, and what is the present value of the glucose level, whether it is improving or not. Okay, so that is also possible with the help of the variable technology. You can set the goals and track your progress with the variable technology. That is possible. Now, what are the cons are there? So battery life is one of the biggest challenge, because I want it should be available to capture the important parameter 24/7. Okay, even though I am sleeping, but I would like that this such kind of variable technology should should be on. Okay, and inaccuracy is the one of the biggest hurdle of such kind of variable technology. Next slide, please. Okay, so future of variable technology is definitely there. Okay, where means I can see that after 2 3 years we are basically habitual of adapting such kind of variable technology. There are some challenges are there where people are working on. Okay, and this will be addressed very soon. Okay, the visibility. Okay, their battery life, authentication, and privacy and security. So these are the challenges of the variable technology that we need to address it. Next slide, please. Now I will talk about some of the application. Okay, possibly I have maybe 10 15 minutes, so I will quickly go through it. uh, One of the application where I have worked on, it is a diabetes, for a diabetes patient. Okay, so for a diabetes patient you need to measure the glucose measurement. Now if you look at current scenario, if I want to measure the glucose, then either I need to go to a laboratory, or maybe I can have a purchase of some sort of self monitoring device. I can use it at my home. Either of the way, ultimately you need to pinch inside your body and take out the blood, which will create a trauma. Okay, ideally if you are a diabetic patient, then you need to measure your body blood glucose at least 3 to 4 times in a day. Okay, you just think about the scenario where you need to pinch inside your body 3 4 times in a day, and that you need to do it throughout your life. Okay, so that is creating a trauma. So there is no such smart healthcare solution which is available. Next slide, please. Next slide, please. Yes. Next slide. Am I audible? Okay. So we have developed one of the device which we term as a iGlu, intelligent glucometer. Okay, where we are actually measuring a body blood glucose value non-invasively. Okay, so we have one startup also which is being incubated at our institute MNIT. Now over there you need to just insert the finger, like you are using a pulse oximeter. Okay, you need to insert the finger, and through which you can able to judge the body blood glucose value. So we have used a 3 sensor, okay, with a specific wavelength. Okay, so I'm not going in much details, but what is the simple principle is that it is based on optical detection. So whenever a light is being incident onto your fingertip, okay, and inside your blood, if there is a glucose particle, then definitely there will be a variation of the light intensity which you receive at the receiver end. Okay, so according to the glucose particle present inside your body, the intensity variation will be observed at the receiver end, and that particularly intensity variation we are mapping it to a machine learning model, and that actually help us to get the prediction of the body blood glucose value. Next slide, please. Apart from that, in a smart healthcare mechanism, it could also help you to go for an insulin dosage. Okay, so for being a diabetic, the problem is the insulin generation. Okay, so ultimately through a medicine, you need to take an insulin, or maybe if you are a type 1 diabetes, then you need to inject the insulin. Okay, so either way, insulin has to be injected inside the body. So what we have done it, we have make a closed loop system where through our glucometer, you can measure the body blood glucose, and you can also adjust the dose of the insulin which is being required at present. Okay, most of the time we are taking a medicine, at that time we are unaware about the what is the actually the insulin requirement of the body, but with such kind of smart healthcare mechanism we can actually track them. Next slide, please. The next application where we have worked is a upper limb prosthetic control. Okay, so here basically means we have developed the robotic arm. Okay, now arm is one of the very important organ of our body. Okay, now mostly we our 80% of our tasks we are doing with the help of the arm only. Now consider a case that those people who are not having an arm, but the good thing is that if you are not having an arm, that your brain is still working. Okay, and your brain is responsible to have any movement of your body. Okay, so that's why there could be a case that we can have some sort of brain computer interface kind of application where through brain we can actually control the robotic arm, and through which that prosthetic people can perform their daily activity. So next slide, please. So what we have done is that we have used the EMG based prosthetic control. Okay, so EMG is a signal which you can actually capture at the muscles of your body. Okay, so of course the signal is being generated from a brain. Okay, but it is traveling through a spinal cord and it will reach to a muscles of your body. Okay, so you will understand the brain intention at your muscles part, and you will decode it what brains want to do. Okay, according to that, whatever the pattern is being recognized by a pattern recognition mechanism, through which you can send the command to a robotic arm. Okay, so it's like that if I'm opening my hand, then means how and what are the command has to be sent to a robotic arm. If I want to close my hand, then what are the command that you need to send it. So there are two-step process. Okay, first thing is from a brain, whatever the command is being generated, that you need to decode it at your muscles, and in the second step, after decoding it, whatever the command that you need to send it to the robotic arm, that has to be performed. So that is the application that we have done it. Okay, next slide, please. Another important application where still much focus of the researcher are required. Okay, we have done some preliminary work, but still it is an open problem. Okay, which I am trying to mention it right now. Intelligent diet control mechanism. Okay, now of course being a diabetic patient, you need to manage your diet, and in general also that possibly people are now more concerned about the how much calorie they used to eat. Okay, because we are now very health conscious that we should have a this much weight only, we should have a this much of body mass index, like that. Okay, so for that you should understand what you eat and what you not to eat. Okay, so most of the time when we purchase a packed food, at that time you can able to know the what is the calorie inside it. Okay, but whenever we are taking a meal, okay, like means I'm consuming some fruits, okay, or some vegetables, or in a simple sense that I am taking my lunch, okay, and there are few things are available at my thali. Okay, so now how much calorie I need to consume by eating those items. Okay, maybe 2 chapati, 2 sabji, maybe 1 gulab jamun. Okay, so how much calorie I would consume by this? Okay, that I would like to know in a forehead. Okay, so before that only, before consuming that, I should able to understand that what amount of the calorie I supposed to get it. Now, according to that, you can decide. Okay, most of the time we are relying on dietitian that if I am suffering from this disease or possibly I want to reduce my weight, then possibly we used to follow the dietitian instruction. But here, maybe through a mobile phone only, you can do by yourself only, because it could be a case that I am taking 5-10 items in a day. It will be very difficult to connect or ask everything to the dietitian. Okay, so what could be done, that whenever you are taking any you are consuming any food item, you can take a picture and you can just upload that picture onto this application. Now, inside this application, what will happen that there is an algorithm which actually identify what is the food product. Okay, so it is simple image classification problem. You need to classify the image and you need to classify which is the particular food product is there. Now, good thing is that there is a database which is available, which actually tells you that what is the nutrition value of that. So it is something like that if I take 1 chapati or if I take 2 chapati, then what is the tentative calorie that I supposed to consume it? If I want to take a rice, okay, 1 bowl rice, then what will be the calories inside it? So that database is available. So what you can do it that with the help of those database, you can actually identify the amount of the calorie which you supposed to consume. And maybe according to that, you can filter it out that what can be eaten at this particular moment or not. Now this we have integrated with our glucometer as well. Okay, so what it will help you in that sense that if my currently the blood glucose value is this X value, and if I consume this particular food item, then what could be my next blood glucose value. Okay, so that can be predicted, and according to that, I can decide that what I can eat it. Now, see, means in a smart healthcare, you can actually develop a very good personalized solution. Okay, now usually when we talk about a smart healthcare, then we are using some AI ML algorithm. The good thing of the AI ML algorithm is the data that you feed it into that particular system and you train it, the better the output you can get it. Now, if I provide a personalized information to that particular system, and out of that, if I am getting a prediction, then definitely it will be very good for a personalized solution for me. Okay, and that is one of the very good way that you can actually go for a intelligent diet control mechanism. Next slide, please. Robotic application is one of the very important, we will play a very important role in the healthcare domain. Okay, where even you have seen it that drone are basically used for the food delivery purpose during the COVID time. Okay, even the medicine could be delivered through a drone. Even robotic surgery is possible right now. Even through a robots, we can collect the sample of the COVID patient as well. So these all things are being practiced right now. Okay, and in the upcoming generation also, the robotics will play a very crucial role in your healthcare domain. Next slide, please. Industry 4.0. Okay, so that will allow you to go for a smart manufacturing, smart production. Okay, and with a smart transportation. Okay, so here what is important is, like we have seen the COVID. Okay, and that possibly it is not the end of the such kind of disease. Okay, there could be a case that we could have another kind of similar crisis in future. So at that time, possibly we can think about some intelligent mechanism where I can predict according to the database that what is the most vulnerable area inside India. Okay, like if I consider a population wise, then population wise maybe the whatever the population of UP and maybe Gujarat and Rajasthan. That similarly there is not such much population. Maybe you can consider in the northeast region. Okay, so now apart from that, you also need to consider that how many such kind of people who are vulnerable for such kind of virus attack. Okay, so usually those who are having a high blood pressure, diabetes, okay, they are suffering from some sort of chronic illness, they are more likely to be stuck with such kind of virus attack. So maybe you can predict and estimate that if such kind of virus attacks happen in future, then what are the best way I can manage my resources, okay, according to the population and according to the vulnerable patients. Okay, next thing, please, next slide. Now, trusted food supply chain management, that is very important, okay, and this problem to be addressed sooner or later, okay, because everybody is talking about now immunity, but we don't know when we are consuming a particular food product, that particular product contains that much of energy or not. Now, if it is being not so, then it can have a vulnerable effect, okay. So possibly packed food, you have an expiry date, but you don't know about the fruits and vegetables, okay. It could be a case that when you are purchasing, at that time only the date has been expired for those items. So now what could be the case, that there could be some sort of smart way or smart mechanism through which I can also identify the life cycle of this particular food products. So life cycle, I mean that when this has been grown, when it has been transported, okay, when it is available as a consumer to me, okay, and possibly the important thing is I need to also understand the shelf life, okay. That means if I purchase a particular food item, then how much time I need to keep it at my home, okay. So such kind of technology has to be developed. It should be something like that when I have put something inside my fridge, then fridge itself should tell me that this food item is lying inside your fridge, and this is the deadline for that, so that you can better way you can consume it in a better way. Next slide, please. So I will talk about the challenges in maybe in next 2-3 minutes, okay, because we are running out of the time. So please, next slide. So data privacy and security, that is very important. See, we are talking about our healthcare record, and which is very personalized, okay. So that here what is important for us, that we need to actually maintain the privacy of that particular patient, okay. So just a minute. So what is important is that private information which we are storing at the cloud, it is personalized information for a patient. So if I am suffering from a disease, I do not want to announce it, okay. So that privacy rights has to be preserved, okay. Security is very important, that whatever the data is there at the cloud, okay, that data should be secured enough, okay, and it should be visible to only closed loop people only. Next slide, please. Security of the variable device is also very important. That means whatever the sensor data I'm using, whether those are the genuine sensor or not. So hardware security is very important, okay. So what are the things that is available in my smart healthcare mechanism? Those things should be protected, okay. It is not like that anyone can access those particular device, or ultimately the security is very important, and it is a paramount parameter of my smart healthcare mechanism. Next slide, please. Power management, that is also biggest challenge, okay, because I would like to have a variable device. Variable device is definitely portable, so it is battery operated. So when it is a battery operated, then I should have a better power management. It is not something like that if I'm using some variable device that I need to charge it twice in a day, okay. So ultimately the better power management mechanism has to be there. Next slide, please. Interoperability, that is very important, okay. So it is something like that I am using one particular sensor to generate the data, okay, and then I am taking a decision to control it, but that is a another company product. So it is something like that through a Apple Watch, I want to control a device which is being generated, which is being supplied by a Samsung. So now this is some sort of security protocol breach, where the Apple device is controlling your Samsung product, okay. So definitely as a user, there should not be restriction on me that I should purchase possibly a particular product from this company only, or maybe all the product at my home from the same company. It should not be like that. I should have a choice, okay. So for that, the interoperability is one of the very important parameter in a smart healthcare, where I want a connected network, okay, where device should talk with each other, but at the same time, they should also have some sort of common protocol through which they can communicate seamlessly. Okay, so that is the interoperability I mean. Next slide, please. Okay, so finally, ICT and IOMT will play a very crucial role in a smart healthcare mechanism, which will transform the traditional healthcare to a smart healthcare. Of course, there are opportunities are there, okay, where we can have a imbibe the intelligence and we can have a personalized care mechanism in a smart healthcare mechanism. There are challenges, okay, that we have discussed, that power management, interoperability, security, privacy, that has to be addressed. So still we can consider that they are not mature enough, but I can see that in next 3-4 years they will be matured enough and we will be using it very extensively in our daily life. Okay, so with this I am stopping it over here. Sorry for exceeding some time. Okay, so but now I'm open for any question if we have a time. Otherwise, maybe people can ask me at offline at any moment through mail.
Yes,
Okay.
sir. As we are running out of the time, participants are requested to contact Sir as in when you required his help for your research work or maybe any other work related to his area. Thank you so much, sir, for your insights and the knowledge that you have shared with us. So here we are concluding the keynote session, and we are very much thankful to all three honorable keynote speaker we have with us today. And all participants are requested to turn their videos on to take a screenshot for this very good session. Just give me a second. As we have multiple grids, it takes a time for taking the everyone in a picture. Thank you so much. And you are requested to join your respective track for the presentations at 12:40 sharp. Thank you.